right, so today, Chapter 8 review. So one of the things you have to remember is there's a quiz part of this I never gave you, and that was the one on fractions. So hallelujah, I took away the hardest quiz, so that should help you quite a bit, okay? So half this chapter you should already know. You should already know. So let's go through it. Number one, I'm just going to break it up, right? I'm going to go, square root of 16, square root of 2, because it is just square roots, right? I'm looking for perfect squares, right? 16 out of 2 makes 32, but the square root of 16 is a perfect square because we know the square root of 16 is 4. Square root of 16 is 4. Okay, and then I'm just going to finish it up. I'm going to go the 5 times the 4 and go 20 square roots of 2. Okay, that's it. And you guys should definitely know how to do this. It's Algebra 1 stuff. My Algebra 1 kids can do this, so you should be able to do this. Okay, example 2. There is no good square root of 10. It won't break up, so you're going to have to leave that alone. But we're going to break up the x to the 5th. So I'm going to go 5x here from that 5x. I'll leave the square root of 10. But with the x to the 5th, what I usually do is half the exponent. And I don't want to take half of an odd number because then what it does is it gives me a decimal. So we're going to change this to x to the 4th and a x. So I took 1 away from the exponent to make it one that we could take half of it, okay? So then I can take the square root of x to the 4th. I can take half of that exponent and I can make it an x squared. So I took the square root of x to the 4th, took half of that exponent, make it x squared. The square root of 10 is not reducible, and the x is not reducible, so let's put those back together. We'll put them back inside the square root together, 10x. And then finally I'll finish it up by tidying it up and make it a 5x cubed square roots of 10x. Okay, that's my answer. Okay, so the trick here was really taking and making an odd exponent even. The trick here was making an odd exponent even, so I took 1 away from it to make it even so I could take half of it evenly, okay? Number 3 is pretty easy. It's just going to be the square root of 49 over the square root of 81. The reason I say it's easy, because they're both, thank you Megan, that's your job. I appreciate you, I do. The reason I say it's easy because they're both perfect squares. The square root of 49 is 7, and the square root of 81 is 9, and so it's just 7 ninths, okay? 4, I've got really the square root is 8 over the square root of 7, so I'm just going to write, right, thank you Megan. And so the trick is you can't have a square root in the denominator, so again, you fix the problem with the problem, right? So we multiply by the square root of 7 over the square root of 7, okay? I'm going to get the square root of 56 over the square root of 49, which is 7. Now, square root of 56 can be broken down too. And I know it could have been broken down because of the 8, right? Probably should have done the 8 first. Well, it would have made it easy if I'd broken down the 8 first. Can I back up? Do you mind if I back up a little bit? Can I back up? I want to back up. The 8 can be the square root of 4, square root of 2, right? Sorry about backing up. This is just going to make it easier for me to do it. Square root of 4 is 2. So I'm going to get 2, see the 2 times, and this is going to be square root of 14 over 7. That's a better answer. You want me to do that one again? Do you want me to try that one again so it's not so confusing? Yes, no?
Wait, the 7 from 49, right?
Yeah. Am I okay? You don't want me to do this one again, you guys? Okay, all right. 5, I'm just going to multiply. I'm going to get 12 square roots of 75. And I want to break down 75. I know that 25 and 3 and 25 is a perfect square. So I'll go 12 times the square root of 25 times the square root of 3, right? Square root of 25 is 5, so I'll have 12 times the 5, because square root of 25 is 5 times the square root of 3. And then I'll get an answer of 60 square roots of 3. Okay? How am I doing, okay? Can I go below my nose? Okay. Number 7. We're just going to distribute. Oh, number 6. Screw over number 6. Multiply. 6 is just a bigger version of 5. I'm going to get an 8x to the 4th. Okay. 4x cubed times 2x. Multiply the square root, so I get a square root of 8x to the 6th. Okay. I can break down the 8 inside the square root, right? I can break that down into 4 and 2. Just broke down the 8, so I can rewrite the 8x to the 4th down next to it. And then this 6. I can take half that exponent because it's an even number. So I'll take half of it. Square root of x to the 6 is just plain old x to the 3rd. Okay, so I'm pretty much close to being done. I just have to tidy it up a little bit. Square root of 4 is 2, right? Okay, so let's see what's on the outside. I get an 8 times 2 is a 16. I have an x to the 4th with an x to the 3rd makes an x to the 7th. Square root of 2. That's all she wrote. 7. Let's see, I'm going to go this times this, which gives me a 20 square roots of 25. And then I'll go 4 square root of 5 times negative 2 makes a negative 8 square root of 5. Okay? Well, the square root of 25 is 5. And I know 20 times 5 is 100 minus 8 square roots of 5. Now we're subtracting. So if we subtract or add, they have to be the same, and they aren't. So I'm done, because I cannot subtract them. That's as far as I can go with that. Okay, how am I doing? Okay, thumbs up. Not too fast. My pacing's okay. All right. All right. Number 8. So it's a FOIL problem. I'm going to get 14 square roots of 49, right? I'm going to get minus 2 square roots of 7. Positive 7 square roots of 7. And a negative 1, or subtract 1. Okay, just FOILing. Okay, square root of 49 is 7. And what is 14 times 7? I don't know. 343, I think. Hold on. 14 times 7. Nope, I wasn't even close. 98. So this is 9. There's my 98. Okay. These two are the same. So if they are the same, you can add or subtract them. So that's going to make a positive 5 square roots of 7 minus 1. Finally, I'll make this a 97 plus 5 square roots of 7. How am I doing? Okay? So if I slide it over, Alexa, wait till you get it, okay? You tell me when you got it, okay? Okay, number 9. So this one's actually pretty easy. If they're the same, add them. If they're not, don't. These two are the same, right? So I've got 5 minus 6. 5 of these minus 6 of these makes a negative 1. Square roots of 5. And then there are no other square roots of 3, so I'll just go plus 8 square roots of 3. And that's it. I can't add them or subtract them unless they're the same, and they're not. 10. Oh, 10, they don't look the same, but I have a feeling if I break them down, reduce them, then I can make them the same. So 27 could be the square root of 9 times the square root of 3, right? 48 can be the square root of 16 times the square root of 3. That's the best one. And you can go 4 and 8, but then you got to break down 8. I like 16 and 3 because it goes faster. Okay, so then I'm going to have 3 square roots of 3 plus 3 times, well, the square root of 16 is 4, right? Square roots of 3. Okay, I'm getting closer. Just breaking it down. That's a 12, right? That's 12, so I'm going to have my 3 square roots of 3 plus my 12 square roots of 3. And they are both square roots of 3, which means I can add them. to get a total of 15 of the square roots of 3. Okay, how am I doing? Now I got a 4th root. Well, let's see. What times what times what times what makes 16? Try 2. Let's check it out. 2 times 2 is 4, times 2 is 8, times 2 is 16. So 16 is a perfect 4th root. So the 4th root of 16 is plain old 2. And then instead of taking half the exponent, I'm going to take a 4th of it, okay, and I can take a 4th of 12 and make it x to the 3rd. Twelve is a little bit different, but I just discovered that the 4th root of 16 was 2, so let's break 32 into a perfect, let's break it into 16 and 2, because I know what the 4th root of 16 is. So I'm going to say, okay, well, I know that if I do the 16 and 2, I know 16 times 2 is 32, but we just saw that the 4th root of 16 is plain old 2, so we can take the 4th root of this term and make that a plain old 2. Now I'm going to come back, and just like here, I took the 4th root of 12 and I took a 3rd of it. I'll do the same thing here. Take the 4th root of this 12 and I'll get an x to the 3rd, because I take a 4th of it, which makes an x to the 3rd. And this 4th root of 2 is just an ugly decimal answer, so we're not going to get the decimal. We're just going to leave it as a 4th root of 2. Okay. Hey, this is like the warm-up, huh? I think this is the one that, Savannah, did you do this one? Or was it Sarah that did this one? Oh, hold on, of course. Middle of recording.
Sarah did it.
Middle of recording, I'll get a phone call, of course. Hello? Oh, she's on her way. Kinsey, you gotta go see Lori. Okay? You gotta go see Lori in the office. Okay, let me keep going now that we are live and recording. What the heck, right? Okay, so the rule's the same. If we go back up to number 4, you can't have a square in the bottom, right? Well, the rule's the same, except you can't have a cube root. This is a 25. So let me first rewrite it as 2 separate cube roots. This one Leora did, didn't it? Isn't it?
No, it was Sarah.
It was Sarah? Okay,
Oh, wait.
now.
Was it?
Oh, maybe it was Leora.
Okay.
So the problem is that we need a perfect cube root. We need a perfect cube root down here. 25 is not. If you took the cube root of 25, you'd get a really ugly decimal. We want a nice number. And so again, we want to make one of these numbers on the bottom. How about 125? Okay, so we can multiply top and bottom by 5, right? But I'm going to multiply top and bottom by the cube root of 5 over the cube root of 5, because that'll make a perfect cube root. So on the bottom, or the denominator, is what it's really called, we're going to get the cube root of 125, okay? Which, that's kind of nice because it becomes plain old 5. The numerator, we really can't do much with it. We multiply it, make it a cube root of 15. It is an ugly number, but we don't care if we get an ugly or irrational number on the top. But in the bottom, or the denominator, we do. So we can take the cube root of that, which is plain old 5, and up on the numerator, we'll just leave it as the cube root of 15. Okay? There, we've rationalized the denominator, okay? Okay, slide it over. How am I doing? Okay, so negative exponent. If I have a negative exponent, I'm going to start with 1 over, okay? Let me highlight that, okay? You got a negative exponent, so right off the bat, 1 over, okay? Negative exponent, make it 1 over. And then, the bottom number is the root, and the top number is the power. So we rewrite this as the 5th root of 32 squared. 5th root of 32 squared, okay? Now I'm going to do the 5th root of 32 first. So what times what times what times what times what makes 32? It's got to be 2. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. So I really get 1 over 2 squared, which makes 1/4. Okay, 15. Well, 1/3 power means cube root. So I'm going to rewrite this as cube root of 27 x9 y6, right? Cube root of 27 is 3. I'm going to take a third of the exponent and make it x3, a third of the exponent and make it y2. How am I doing? Okay. 16, I'm going to have to do 16 on a separate sheet of paper. I'm not going to have room to do 16. So I'm going to slide 16 on another sheet of paper, okay? So let me write it. 16, 5 over 3 minus the square root of 5. Okay. Now before I do it, I'm going to show you why it won't work the other way, okay? If we're to multiply by square root of 5, square root of 5, square root of 5, square root of 5, which I'm not going to do, but if you did multiply by the square root of 5, square root of 5, this won't work. You'd wind up still having a square root in the denominator. It won't go away. So you have to multiply by this thing called the conjugate. And the conjugate is the opposite. So I'm going to go ahead and multiply top and bottom by the conjugate. Now the conjugate is this 3 plus the square root of 5. I'm going to do that top and bottom. 3 plus the square root of 5. Okay, you have to do it by the opposite, both top and bottom. Okay, it's called the conjugate. Well, let's see how that's going to help. All right, so I'm going to get 15 plus 5 square roots of 5 over 9 plus 3 square roots of 5 minus 3 square roots of 5 minus the square root of 25. Okay, now the reason we want to do that is when you take a look at doing the conjugate, these two cancel. You have a square root, but the square root of 25 is 5, plain old 5, so you're going to wind up with no square roots in the denominator. All right, let me keep going with this. So this becomes 5, right? Plain old 5. So I'll have a 15 plus 5 square roots of 5 over 9 minus 5 is 4. There's your answer. And there is no longer a square root in the denominator. We cleared it. We rationalized it, okay? All right. Let you catch up, write that down, then we'll move on to number 17. All right, 17. Boom. Here we go. Let's see, I'll squeeze 17. I'll squeeze 17 over here. Okay, 4th root of 81 over the 4th root of x cubed. Okay? All right, let's see. I think 3 times 3 is 9. Times 3 is 27. Times 3 is 81. Wow, that's cool, okay? So 81 is a perfect 4th root. 81 is, the 4th root of 81 is, boom, plain old 3. Okay? Over the 4th root of x cubed. Okay? Now, what I'm going to do is make this a perfect 4th. If I can make this x to the 4th, right? If I can make this x to the 4th, then they'll cancel, right? Well, that's easy. I'll just multiply by x over x. So I'm going to multiply top and bottom by the 4th root of x over the 4th root of x, right? And by doing that, I'll get a perfect 4th root on the bottom. So in the top, on the numerator, 3 times the 4th root of x over, well, I get the 4th root of, thank you, 4th root of x to the 4th. Okay, that's why I did this, because now I've got an x to the 4th on the bottom. And that's just going to become plain old x, because that will become plain old x. So in the bottom or the denominator, we'll have x. And in the top or the numerator, I'll have 3 times the 4th root of x. There's my answer. Okay, ready to turn the page? Yes, Simon.
Why did the x cubed turn into x to the 4th?
Here, right there. I wanted to rationalize it, so I wanted to get rid of a root out of the bottom, right? So I can make it, by multiplying by x over x, I make it into the x to the 4th. And once I make it x to the 4th, I can take the 4th root of it. Does that make sense? Okay, so I needed to rationalize the denominator. Okay, turn the page. All right, graph. This is actually, I'm going to do just a real easy graph. This is not too bad. Okay, graph this. Get my graph paper out. You don't really need graph paper necessarily, but I'm the teacher, so I'm going to try and do a really nice job. You'll appreciate the fact that I'm going to try to do a nice job for you. All right. So, I'm going to go. Here we go. There we go. So my end point is at -2, -1. Remember, it's going to be the opposite of the inside, right? I'm going to do the opposite inside. So that I'm going to go to the point -2, -1, okay? And since I'm doing square root, the square root's half a parabola. It's half a parabola. And so I want to use these numbers. I want to use 0, 1, 4, 4, and 9, because there's a square root of 4 and a square root of 9. So I'm going to go from the endpoint, I'm going to go over 1, and I know the square root of 1 is 1. Go back to my endpoint, I'm going to go 1, 2, 3, 4. Square root of 4 is 2, 1, 2. There it is. Go back to my endpoint, 1, 2, 3, 4, 5, 6, 7, 8, 9. Square root of 9 is 3. Okay, and it keeps going, but I don't need all the rest of them. Okay, so just, okay, there's my graph. Now, what I won't graph is anything back here because those are negatives, right? So it stops here. And it doesn't go down here because it's a square root, okay? So now, let's think about domain. Well, one of the things for sure is domain starts here at -2, x value of -2, right? And it goes forward. It does not exist back here. Domain's all possible x values. So it's just x is greater than or equal to -2. That's my domain. My range, reach for your range, well, it starts at a height of -1 and goes up. It does not head down here at all. It starts at a height of -1 and goes up. So my range is going to be y is greater than or equal to -1. That's my domain and my range. Okay. All right, whisk this away. There we got it. Okay, then finally, last ones. Okay. So, square both sides, right? Oh, I might need a separate sheet of paper to do some of these. It's okay. I'm gonna. Huh? That's right. You guys do it below. I'm gonna do it on a separate sheet of paper, right? So if I square both sides, I have a 2x equals 144, right? Divide by 2, x equals 72. And 72 makes sense. If I were to plug 72 in, I would still have a positive value. So I'm okay. That's a good answer. 22. Let's square both sides. Because the square gets rid of the square root. So I'll have an x minus 5 equals, what is it, 225? I think so. 15 squared is 225. Almost positive it is. Yeah, 225. Plus 5, x equals 230, okay? And again, pretty sure that's going to work. If I plug it in, yeah, it's a positive value, so I'm good. All right. 23. Well, again, square both sides. I guess this one's pretty easy. Square it, right? I have a 8x minus 5 equals a 2x plus 4, right? I'm just going to solve. Minus 2x, 6x minus 5 equals 4, right? Plus 5, 6x equals 9, right? Divide by 6 and I get 9, 6. It's an okay answer. Or 1.5. That's an okay answer. Or x equals 1.5. Okay. This is easy, huh? It's easy. Your last quiz shouldn't be too hard. All right. Am I going too fast? Am I good? All right. 24. Here comes our first kind of tricky one. But it'll be easy. Okay, Mason, we're going to square both sides. Square, right? Now, the square cancels the square root. X plus 18 equals. Are you watching? Everybody watching? Are you watching? This is going to be x squared minus 4x plus 4. Whoa! Whoa, where did that come from? Where did that come from? Well, we're smart. We know that x minus 2 times x minus 2 is just a FOIL problem, right? It's just a FOIL problem, right? X minus 2 squared is just a FOIL problem. So we get the x squared minus 2x plus 4, right? If we FOIL, but you guys know how to FOIL. So we wind up with x squared minus 4x plus 4, okay? Now I have a problem. I'm going to get 2 answers. How do I know I'm going to get 2 answers? Where are the... Yes, Caleb.
Because it has a square.
Guys agree? So we're going to get 2 answers. Let's find out. So, which means I'm going to have to go back to doing the F word. I'm going to have to factor. So let's do some factoring. First, let's bring over the x minus 18, minus 18, right? So to factor, I've got it set equal to 0. X squared minus 5x minus 14, right? Factor, right? X and x minus 7 plus 2. You guys okay with that? Because that'll make a negative 14 when I multiply them, but they'll add to a negative 5. Of course, we know the answers to the opposite. X is equal to 7 and x is equal to negative 2, right? Say wrong, Mr. Davies.
No.
What's wrong?
Negative 2 doesn't work.
You can't use a negative 2 because if you put the negative 2 in here, you get a square root equal to a negative value. It can't be, so we throw out the negative 2 and we just have the 7. Almost done, you guys. Almost done. All right. 25. 25 is very...
Where's 25? Oh, yes, I'm blind.
25, that's okay. Not as blind as I am. 25 is actually pretty easy. 1/3 power is the same thing as cube root. Okay. Cube root. We'll get rid of the cube root by cubing both sides, okay? Because that'll cancel it, right? So we'll be left with an x plus 5 equals 64. Because 4 times 4 is 16 times 4 is 64. Minus 5, x is equal to, what's that, 59? There we go. Okay, and I have your very last homework assignment for you. Very, very, very last homework assignment. Page 637.
Oh, we are.
222 even, so it's just 11 problems, that's it.